Hey everyone, imagine asking an AI not just for answers, but to actually use a computer to solve your problem. Not just writing code, but running it, not just explaining a workflow, but executing it. In March 2026, researchers and engineers at OpenAI published an engineering deep dive titled From Model to Agent, Equipping the Responses API with a Computer Environment by Boshu Danijang and Rohit Arunachalam. And the idea is simple but powerful. Instead of a model that only talks, you get a model that can act. This is the story of how language models evolved into agents that can operate real computing environments. Traditional large language models are amazing at reasoning and generating text, but they have a fundamental limitation. They can only produce outputs. They cannot directly dash run shell commands, inspect files, execute programs, interact with real systems. So if you ask a model to solve a multi-step task like debugging code, installing dependencies, or running experiments, the model can only suggest what to do. A human or another program has to execute those steps. That gap creates friction. To build real AI agents, the model must do more than generate text. It needs access to tools, and it needs a system that coordinates the conversation between a model, the tools, and the computing environment. This is where the Responses API comes in. The Responses API is the interface developers use to interact with OpenAI models. But more importantly, it acts as the orchestrator. When a user sends a request, the API builds the model's context. This context includes the user prompt, previous conversation history, instructions about available tools. The model then analyzes this context and decides the next action. Sometimes the action is simple, return a text response, but other times the model might decide to use a tool, for example, run a shell command. When that happens, the Responses API forwards those commands to a container runtime that executes them. The output is streamed back to the model, and the model continues reasoning with this new information. This process repeats in a loop until the task is complete. This architecture creates something called an agent loop. Here's how it works step by step. Step 1, the user sends a prompt. Step 2, the model reads the context and decides an action. Step 3, if the action requires a tool like a shell command, the API executes it. Step 4, the system streams the results back to the model. Now the model sees what happened. Maybe the command succeeded, maybe it failed. Based on that output, the model decides the next step, run another command, inspect a file, or finish the task. This loop continues until the model produces a final response without requesting more actions. And suddenly, the model is no longer just answering questions, it's operating a computer. One of the most interesting parts of this system is real-time streaming. When a shell command runs, the Responses API maintains a live connection to the container. As the command produces output, the system streams it back immediately. The model can observe the results as they happen. This means the AI doesn't need to wait for a process to finish. It can watch the logs, analyze partial results, and decide whether to continue or interrupt. Think of it like a human developer watching a terminal window. Except now the AI is the one reading the logs and deciding the next move. This dramatically improves the model's ability to complete long multi-step tasks. The Responses API doesn't just support shell commands, it includes a growing ecosystem of built-in tools. Examples include web search, file search, code execution, image generation, computer interaction tools. These tools allow models to interact with the real world. For example, web search lets the model retrieve real-time information. File search allows agents to analyze documents. Code interpreter tools enable complex data analysis and programming tasks. When these tools combine with reasoning models, you get something far more powerful than a chatbot. You get a task-solving agent. This architecture changes how developers think about AI. Instead of writing code for every workflow, you can define the environment and the tools. Then the agent figures out how to solve the task. This approach enables systems that can debug code,
run experiments,
analyze data, automate software engineering workflows. In fact, OpenAI has already used similar systems internally to build software with AI-driven agents collaborating with engineers. The role of the developer shifts from writing every line of code to designing the systems where agents operate. Of course, Giving an AI access to a computer environment introduces new challenges. Security becomes critical. Agents must operate inside controlled environments, often isolated containers. Commands need monitoring. Permissions must be restricted, and safeguards must ensure that agents cannot perform unsafe actions. These engineering constraints are essential to making AI agents reliable and safe. For years, language models have been incredible at thinking. Now they are learning how to act. With systems like the Responses API and tool driven agent loops, we're witnessing a transition from models that generate text to agents that can complete real tasks. And this raises an exciting question. If AI can already operate computers, what happens when it starts running entire systems? The next chapter of AI might not just answer questions, it might run the world's software. If you found this helpful, hit like, subscribe, and comment which AI system you want to build next. Stay sparked. See you in the next video.